Hello and welcome back to another episode of Measurement in a Minute. I'm your host, Justin Kozak with Lakeside Process Controls. And in today's video, we're continuing our discussion around RoseMat and micromotion flow meter technologies. More specifically, we're diving into the next set of videos talking about two-phase flow or entrained air applications. Now, before we get into that, let's talk about what is entrained air, and then later we'll talk about why this is a problem. Now, entrained air can be described as when a gas is present in a liquid stream. It's going to occupy some sort of volume, just like you see pictured behind me. This is important because most flow meters are designed to handle a single phase fluid, either all liquid or all gas. And when you have a mixture of the two, this can present some challenges. Now, although we typically call this, entrained air, these bubbles can also be a variety of other things. It could be really any gas. It could be nitrogen. It could be pure oxygen. It could be air as we have it outside. It could be a whole bunch of different things. Regardless, this is going to pose to be some challenges, especially depending on the type of entrained air. So what are the different types of entrained air? Well, we classify them in about 3 different ways. The first one would be called bubble flow. Okay, think of continuous distributed bubbles, typically really small, but they are intentionally added to the process and they are always there. It's important to understand that they're always there because then that means we can't ask our customers to remove those if it presents measurement challenges. We quite often see these in the food and beverage industry. So think whipped cream, or think toothpaste, or even chocolate. Bubbles are added to sometimes help enhance the texture or the flavor, and so we don't want to remove those. Next up, we have what we call slug flow. Typically unintentional and can occur in process upset situations, maybe in a tank farm or an oil well, where these bubbles are periodic and coalesce together. And here's some great examples. So think of when you have a long fluid stream kind of dropping down into a tank, air can kind of get sucked in that way. Another one is if you have agitator blades, especially if it's operating at low levels in the tank. Think of, swirling around a nice cup of wine to draw in that air to enhance that flavor. That's the exact thing that's happening in your tank there, which is going to draw more air into that process. Or if you have a pump that's maybe emptying tanks that are empty or near empty, that's going to suck in air. Or if you have leaky pumps as well, sucking in air, that's another way that these bubbles can get into your process. We want to avoid these where possible because these can present some challenges and are typically able to be mitigated or at least reduced. And the last one are known as empty, full, empty batching. Don't try to say that 3 times fast. Also unintentional and are characterized more as a precise liquid-gas interface. Think of this as maybe suddenly, closing a valve, unloading a tank, unloading a rail car. In all of these applications, you'll send this direct slug of precise air liquid mixture. In these cases, it'll kind of hit the flow meter all at once, and it'll probably do a direct switch between one phase to the other. Now, all 3 of these types of entrained air do present some challenges. In the future videos, we're going to focus on the latter 2 and how we can help try to reduce these situations and mitigate any sort of measurement effects that we would have. Should you have any questions about micromotions, Coriolis, flow meters, or any other of our technologies, please reach out to us at www.lakesidecontrols.com. Thanks and have a great day.